It is recording. All right. All right. Well, it is time. I'm gonna get started here. And let me get the clock started. Just so that it is easier for you to reference the time when you need to rewatch the video. All right. So what we'll do today is to go over exam one from 1999 because that was the last time I taught this class. And I already gave you the code that is not in the pseudocode format in the announcement. So I hope everybody had at least, I would say, spend a few days, on trying to answer those questions. Because if you don't spend your time to try to answer those questions before I talk about the solution, it's not going to be very helpful. The discussion of the solution is not going to be very helpful. All right. Having said that, I'm going to switch to the screen here, which is the actual exam in 1999, which basically is guaranteeing to you that your exam is not going to be exactly like this. So keep that in mind. All right, so I will read the instructions here. 1999 is before the pandemic, so the test was entirely on paper, just like yours. Okay, so that means in your exam, you can bring any amount of paper or paper-based material with you. It's open book and open notes, but it's not open internet, and you cannot bring electronic devices other than a simple calculator. When I say simple calculator, actually it includes any type of graphing complicated calculator, just not cell phones. Okay, so no cell phone, no tablet, just a calculator and any amount of paper that you want to bring with you. So is that part clear? Okay, all right. So if anyone has been taking notes using a tablet, you might need to consolidate all your notes onto something that is printable and then print it out and bring it with you. You can also bring anything that I have authored, that I have developed. So all the modules, all the sample programs, all the diagrams, and so on and so forth. As long as you can get it on a piece of paper or pieces of paper, you can bring it. There's no limitation as to how many pages you can bring. Are we good so far? All right, cool. All right, so typically you just kind of read the instructions, make sure you read that, and we'll start with question number one. So this is question number one. I give you a trace, and then you have to tell me what you think is the code that generates the trace. Okay, so how do we do this? Okay, because we haven't even done anything like that in class. It is not atypical that in your exam, I will ask you to do something that we have not done in class. But you should have all the knowledge that you need in order to answer the question. That's kind of how I test people. Is I'm not testing whether people can memorize anything. What would be the point of that if it is already open book and open notes? So there's no need to test that. So what I'm really testing is can you apply what you have learned in order to problem solve and come up with the answer? So let's go ahead and take a look at this question. Given the following traits, write an algorithm in pseudocode, not in pseudocode in this class. We actually write C++ code in the given space. Be sure to indicate line numbers as well as the actual code. The syntax of the pseudocode should be the same as the one used in class. So in this class, we use the code. Note that there may be multiple pseudocode algorithms or C++ code algorithms that can produce the same outcome. You also need to explain the rationale of how you infer the pseudocode or C code in this class from the trace explained on the right-hand side of each line of the pseudocode is fine. All right, so what do we do in this case? What do we know for sure that has to be in this particular program? There has to be a variable a. Very good. Okay, so we'll jot down all the important points. And I encourage you to do the same thing when you're trying to answer the exam. In the exam, is to write down your rationale. Okay, so we know that there has to be a variable a. Okay, a is the name of the variable. Okay, and I might want to just kind of change my font, my pen resolution just one notch down. There we go. All right. What else? What else do we know about this particular trace? Hmm. We have. Is there a decision point here? Do you think there is a decision point here where sometimes it goes here and sometimes it goes somewhere else? And where do you think the decision point is on in terms of line number? What I'm asking is if you look at all the lines, okay, one particular line is not always followed by a particular line number. Sometimes it's followed by this, and other times it's followed by something else. So which line number am I referencing? 28. Exactly. Okay. So line 28 is going to line 29 this time, but it goes to post straight right away the second time. Okay. So that means line 28 is a line where there's a decision to make. Is that okay? All right. So we'll write it down. Okay. So as you figure out these things, write it down because even if you cannot come up with the actual code, you might get partial credit just by showing me your analysis process. Okay. Because that really is the important part, not the finished product, but the process that you took in order to get to the finished product. Okay. So we'll say your line 28 is a decision making line. Okay, and if you want to elaborate, you can even go a little bit further. You can say, um, line 29 or post follow line 28. Okay, very good. What else? What else can we observe here? There are three control structures that we have talked about in this class that can make decisions. Can somebody tell me what those three control structures are? You don't even have to mention the name that I use. Just kind of describe it the way that you want to. There are three control structures, three types of statements where it can make a decision and it can go this place or another place depending on the condition. Hmm? A conditional statement, okay. So you can write down on the side, okay. Like there's an if statement. What else? There are three of them. This is one of them. All right. So from yes, go ahead. A do statement. Okay, very good. And then the last one is a while statement. Very good. Okay. So from the hesitation, I would think that most people may need to study a little bit, okay, because you really need to know the statements that we have talked about so far. Assignment statements, those are the only things that can change the value of a variable. A conditional statement, if else, okay, is the kind that can branch, but regardless of which branch you take, they merge and then they continue execution. They never go back. The only two types of statements that can go back would be a do or a while. Okay, both of those can go back. What are the differences between a do versus a while? A do, it's yes. hmm That is correct, okay? As opposed to a while statement where you ask the question first, depending on the answer to the question, you may perform an action or you may go straight to past the end of the loop and continue your execution. That is very true. Okay, so now that we have do, if, do, and while, okay, you look at the trace here and then you ask which one is seems to be correct, okay? So you can see how we go from line 29 back to line 28. Okay, so what is that suggesting? Are we looking at a conditional statement? Is this possible to be a conditional statement? Does a conditional statement go back to a previous line? It has to be a loop, and a conditional statement is not a loop. Okay, so now we can cross out the if. Okay, and we can say your line 29 goes back to line 28. that is the reason why it cannot be an if. Okay, we got two loops here. Okay, is it a do loop versus a while loop? Now we know line 29 goes back to line 28, but it did not, it went back without asking a question. So that means it cannot be which one? It cannot be a do, okay? Because with a do loop, we perform an action and then we ask a question and then we go back, okay? So we can now also say for the same reason, it is not a do loop, it has to be a while loop. Huh? It is, there's just a lag. Yep. All right. So now we know it's a while loop. And in addition to a while loop, what do we have? We see variable a getting updated, right? So that means it has to be a what kind of statement? I just mentioned the kind of statement. The only kind of statement that can change the value of a variable, what kind is it? An assignment statement. Very good. Okay. So now we can also say since a is updated on which line updates variable a? Hmm? There are two lines, right? So one is on line 27, okay, on lines 27 and which line? 29. Very good. All right. So we know those two lines are assignment statements. So we know that lines 27 and 29 are assignment statements. Okay, very good. All right, so I think we got a lot of things mapped out at this point. Okay, but this is the thought process, okay? And the thought process is impossible if you do not understand the statements, the concepts first, okay? And that's what the test is testing, okay? You have to start with the definitions, basically what kind of statements do we have, what do each statement do, and what kind of clue can you use from the trace to indicate what kind of statement am I dealing with here? Is that okay? All right, so now we have a general idea. Okay, so now we say, okay, this is line 27, 28, 29. We got, we don't even have line 30. Okay, um, 27, 28, 29. Yep. Okay, so we can potentially put a line 30 here, but we're not going to need it. Okay, we know line 27 and line 29 are assignment statements. What is going to be, every assignment statement has a left-hand side and also a right-hand side. What do you think is on the left-hand side of the assignment statements? Yeah, it has to be the variable being changed, and we only have one variable in this case. So that has to be variable A, okay? So we know on line 27, it looks like A equals to something and then semicolon. And then on line 29, it also looks like A equals to something with a semicolon. Does that make sense? We know that there's a while loop, and with a while loop, the condition is associated right after the while word. So we know on line 28, it is while, in some kind of condition here. Okay. So we can fill in at least as this much at this point. Okay. So if time runs out in the exam and this is all you can do at the time, you'll get partial credit. You'll get, I would say, probably 2 out of 4 or possibly even 3 out of 4 in terms of partial credit because you have shown me the process, okay, that you go through in order to figure out the most essential part of this question, okay? So now the question is, um, what do I put on line 27 on the right-hand side of the assignment? Okay. Once again, the question says there can be multiple answers, but the first thing is we know that in the precondition, variable a starts with an unknown value, and then for whatever strange reason, after line 27 executes, it ends up with a value of 11. What do you think is the simplest thing we can put on the right-hand side of the assignment statement? Just 11. Yep. Okay. And then we go to the while statement, and as when we go back to line 28 a second time, when variable a becomes 16, it does not go to line 29 anymore. Instead, it exits the entire loop and goes straight to post. Okay, so now the question is, what kind of conditional statement can you formulate that is false when A is 16, but it is true when A is 11? There are a whole variety. You can take your pick. This is the sort of thing where I look at the answers from the class, and if everybody has exactly the same answer, I go like, that is suspicious because there's so many ways I can make the condition true when A equals to 11 and false when A equals to 16. So go ahead. Oh, I thought you raised your hand. No, okay. Yeah, go ahead. Ah, okay. It does not equal to. Okay, well that works. Or less than, just less than is gonna work. Um, there are so many other things you can do. You can say A equals to 11. Okay, that works too. It just has to be consistent and works in both cases. Okay, so based on the comments, which is a clue as to what you can specify here, I'm gonna use exactly that. Okay, when A does not equal to 16. Okay, and this is an exclamation point equal to, that means not equal to. When did we talk about that? Tech, did you actually talk about something like that in your class? And if I did, when did I talk about it? When we talk about conditional statements, yes. Okay, so when you're looking at this test, okay, when you look at this exam, and you are going like, I have no idea when we talk about these notations, that means like a lot of study time. Okay, just because it's open book and open notes, it's not going to be helpful if you don't know where to find that information. Okay, but if you already know where to find that information, chances are you really don't need to find that information. So that's kind of the dilemma of studying versus not studying. All right, so what do we put on line 29 so that after line 29 executes, A becomes 16. There's also a variety of statement here, but the simplest one is just, how about just, no, 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 no. It has to be 16 because after line 29 executes, A ends up with a value of 16. So the simplest way to do it is simply to say A equals to 16, but you can also say A equals to A plus 5. That works too. Okay, so if I put an extra constraint here and go like, on line 29, you cannot have just a constant on the right-hand side, then you can use, A equals to A plus 5. That works too. So are we doing okay so far with this question? Question number one. Mm-hmm. Yeah. So the first part is a familiarity of the content. Okay. What statements do we have? What do they do? What is the behavior of each control structure? We only have three control structures in this class: conditional statement, do loop, and while loop. Okay. So you have to remember, how do they differentiate from each other? Okay. So that's one. Two would be, oh, okay, but what can change a variable? Because on line 27 and on line 29, the variable a has its value changed. And then you have to look at um, how line 29 can be followed by line 29, excuse me, how line 28 can be followed by line 29 of the first time, but the second time, line 28 is followed by post the second time, which means we're done, after line 28 right away, and then we just go to post because the entire algorithm is finished. So now you have to use that as a clue and go like, okay, we know it's a loop, okay, because only a loop can go back to a previous line. But what kind of a loop is it? Is it a do loop versus is it a while loop? Okay, So you have to go through all of those reasonings in order to come to the correct answer. Okay, are we good so far? All right. So that's for question number one of four. And then we just move on to question number two. So question number two, I am going to go back to my website here, and I have no idea where that one is. Hmm, I think it's probably the second. Yep, it's this one. I have to go back to this part here because the question gave you in the PDF it gave you a pseudocode, but since we are not using pseudocode anymore, I have to give you the actual code that we use, which is actually C++ code. So I'm gonna have to do something like this and make this always on top, and then switch back to the screen here, and then just kind of cover this like that. Actually, it doesn't work because I have to maximize the screen. Okay, so once I maximize it, it's not exactly the same place, close enough, like that. Okay, all right. So the question is asking, what is the pseudocode needed to do the following? The condition right after line 23, but the line number do not align anymore, so it'll be after line 20. I want z equals to 0 if and only if x is less than 29. I want z to be equal to 1 if and only if x is greater than 74. X equals z, this is z, so, sorry, it's variable z, is 2 if and only if x is greater than or equal to 29 but less than x is but less than 44. And I want z to get a value of 3 if and only if x is greater than or equal to 44, but less than or equal to 74. Okay, and the question is asking you to fill in C1, C2, and C3. Okay, so this is a nested conditional statement. So one thing you need to do with this particular question is to understand how things are nested. Okay, in other words, drawing a picture may not be a bad idea, okay? Especially for people who are more visual, you might want to draw a picture, okay? Just based on the code that is given to you, we now know that, okay, there's a C1 over here, and C1 can answer true, and can answer false, okay? If it answers true, then we have a second conditional statement that is asking C2, which can also answer true or false, okay? And then over here is the only time z gets a value of 0. And over here is the only time z gets a value of 1. And if C1 is false, we go to the else corresponding to the outermost conditional statement. So we end up on line 17, in which case we ask C3, which can also be true versus false. And if C3 is true, Z gets a value of 2. And if C3 is false, then we get a value, Z gets a value of 4. And then these two merge. These two also merge. Hmm? Oh, you're correct. Okay, so you got it right. Okay, so let me correct that. Take that out. Put that 3 here. There we go. Thank you. Thank you. All right. So that is the flow. So now the question is, were you able to figure out the corresponding flowchart given the source code on the left-hand side of the screen? Okay, so that part is about BNF. Okay, it is really about BNF. Basically, how do we parse the text of the algorithm? Okay, because one thing you have to remember, I cannot really draw that here, but I can kind of point. So this is a conditional statement, okay? From line 12 to line 15, that is the then statement corresponding to line 11. From line 17 to line 20, that's the entire else statement corresponding to the if statement starting on line 11. In other words, we have a nested conditional statement as the then statement of the outermost conditional statement, and we have another statement, conditional statement, as the else statement corresponding to the conditional statement that is at the outermost part of the algorithm. So the nesting of the conditional statement is really important here. Do we have any questions about how to convert from the text of the program to the pseudocode, not pseudocode, but to the flowchart representation of the same logic here? Yes, no, it needs practice. Yep. You need to practice with B and F in this case, and also basically asking, how do we recognize, what type of statement is where and how these statements are related to each other, which one is containing which other one. All right, so knowing this, okay, now we are really asking, we want, by the time we get here, okay, we want to basically confirm that x is less than 29, okay, x is less than 29 by the time we get here. And I'm going to skip all the way to the left-hand side, which is here. By the time we get here, we want to make sure that x is greater than or equal to 44. Okay, x is greater than or equal to 44, and x is less than or equal to 74. Okay, all right. Um, so we'll work with, oh, also the one here. That happens when x is greater than 74. Okay. All right. So given all these clues, okay, how can we structure C1 and C2 and C3? There's one more that I haven't really addressed yet, but we'll focus on z equals to 0 and z equals to 1. So how do we structure C1 so that it would steer anyone who's coming in to the left-hand side, so that by the time we get to C2, we can kind of choose either the left-hand side or the right-hand side, but having everything that is corresponding to the first two lines of the constraints. What do you think? Okay, so I guess one way to put it is C1. Okay, so we can say C1 can be x is less than 29 or x is greater than 74. Does that make sense? Okay. And then the other side, we capture everything that is actually less than or equal to 74 and greater than or equal to 29. Are we good so far? Okay. So that means by the time we get to this branch here, by the time we get through this little loop, little circle here, we know that x is either less than 29 or it is greater than 74 because it cannot be both at the same time. So that means your C2 has a pretty easy job because all it needs to do is to say, okay, given that x is either less than 29 or greater than 74, I just need to know whether it is less than 29 or not. So C2 can be x is less than 29. Is that okay? Now, what is this symbol here? What is the two vertical bar representing? It is a or, exactly. It is a disjunction, but it is displayed like this because that's the symbol that we use in C++. And where do we find this symbol? Have I ever talked about this symbol? And if so, when did I talk about it? Or, you know, conditional statement. It is part of the discussion of what a condition is as an expression, and this is one of the what we call a Boolean or logical operator. Okay, and there's a whole truth table, the whole discussion about or versus and versus not. You know, they're all in the conditional statement module. All right. So now we can focus on the right hand side. Okay. So the right hand side, it means, if we go through this little circle here, it means, x is somewhere, okay, it's greater than or equal to 29 and it is less than or equal to 74. Okay. Does that make sense? Yes or no? Okay. Sort of. Yes. Because that's the two conditions that we need in order to say that by the time we get here, x has to be less than 29. By the time we get here, x has to be greater than 74. So in order to even get into, okay, let me use a mouse pointer here. In order to even make that decision, x has to be one or the other, which means this has to steer into this direction if and only if x is less than 29 or greater than 74. In other words, I work my way backwards. I know what I need to be here. I know what I need to be here, but these two are coming from the same decision point. So that means to even get to this decision point, I need this condition here to specify either less than 29 or greater than 74, which is now written in this particular syntax in the C++ syntax. All right. So now that we know this, on this side, we know, by the time we get through this little circle here, x has to be greater than or equal to 29 or less than or equal to 74. So now I just need to say, hey, by the time, if it is greater than or equal to 44 also, then we go to this branch, which means, C3 has to be what? Can somebody tell me what C3 can be? In other words, what do I need in order for z to get 2? I need it to be greater than or equal to 29. That's without saying anything, right? Because in order to get to the right-hand side, okay, let me use my mouse pointer again. So in order to get to the right-hand side here, okay, okay, that's not working. In order to get to the right-hand side here, um, this condition has to be false. If C1 is false, it means x has to be greater than or equal to 29, and it has to be less than or equal to 74. Does that make sense? If you think about the number line, okay, C1 is saying, okay, if it's beyond this side and if it's beyond this side, then we go to the the left-hand side branch of C1. But if it's within that range, then we go to the right-hand side of C1, right? So that means, we already know by the time we get to C3, we already know that x has to be greater than or equal to 29 and less than or equal to 74. But the only additional decision that I need to make is that x is less than 44 in this case. So that means C3 is just x is less than 44. That's all. That's the only additional confirmation I need in order to steer in the direction of z gets 2, which is right here. And that pretty much finished the whole thing. So once again, okay, so this question is not something that, by the time you get your exam, it's not going to be exactly like this. Okay, I still have not decided on how I want to ask questions in your particular exam, but it will be in the same type of principle, which is, you have to be able to apply what you have learned. Yes. Yep. So X would be, yeah, because of this, right? This is the requirement. This is a criterion that I need to meet, and I need to specify C3 like this in order to meet this criterion. But I don't need to repeat x is greater than or equal to 29 because the fact that this condition is false, and given what how C1 is formulated, I already know that x is greater than or equal to 29. All right, so we gonna do okay so far? Okay, all right. Shall we move on to question number 3? All right. Hmm. You mean in your exam, yes, I have not really decided on, what questions to ask. The the number of questions, well, I haven't decided on that one either. All right, so this one is just a trace, okay? It says you'll trace the execution of this pseudocode, but that pseudocode, we haven't really talked about pseudocode in this class, so I am going to go back to the non-pseudocode, the C code that we use in this class. So that's for question number 3. That's the actual C code. So we'll do the same trick here, right? Just copy and paste sort of into its own little display thing, and then switch back to this part, maximize the tablet screen like so, and then just kind of stash this over here. Okay. All right. So how do we trace? So by doing this, it actually is helping with your homework assignment. Okay, you guys are getting a new homework assignment that's due on Wednesday. You guys go like, but there's only like 2 days in between. Well, this is me trying to get you guys to study because it's the same kind of material on next Monday. So it's good to get the extra practice with your homework assignment. All right. So we know that we need a line number. Okay. And let me see if I can find a piece of paper as a ruler because I can't really draw straight lines very straight. Some content on it already. I don't think it's needed. I'm just going to use it as my ruler. When you don't have a ruler and you have a piece of paper, you just fold it several times until it becomes a ruler. There we go. Okay. So here's my line number. Okay. And how many variables do we have in this particular code? We looks like we got X, we got P, and then we got D. That's it. Okay, so we need one column for P, one column for D, okay, and one column for X, and then one column for comments. There we go. And then we always start with the pre, okay, which is the precondition. In this case, the question did not say anything about the pre-existing values of any of the 3 variables. So they're all going to be starting with a question mark. After line 15, okay, now this is not line 1, it is line 15 for whatever reason. So after line 15, x gets a value of 3. And then after line 16, p gets a value of what, 16. Okay, that's coincidental. And then after line 17, d gets a value of 0. And then when we get to line 18, no variable is updated on line 18, but we have to answer the question, what about x does not equal to 0? Is that true or is that false? What do you guys think? X does not equal to 0 is it true or is it false? It is true because x has a value of 3. 3 does not equal to 0 is true. Okay, all right, so we do that. And then where do I go next? The condition of a while is true. So where do I go? Line number 19. We go into the loop, okay? We perform whatever the loop is trying to specify. So now we go to line 19. Line 19 says d gets d times 10. And since d is 0, if after you do the multiplication by 10, it is still a 0. And then we get to line 20. Okay, line 20 is a if statement. Okay, it is saying if x is greater than or equal to p, we do something. So what is the condition? So now I repeat here, x is greater than or equal to p. Is it true or is it false? X has a value of 3, p has a value of 16. X is greater than or equal to p is false. Very good. So now where do we go? It's a conditional statement. It doesn't have an else. Okay, the else portion is optional to a conditional statement. So where do we go after we evaluate the condition on line 20 and say, oh, it is false? Where do we go? Sorry, line 24. We That is correct. Okay, we go to line 24 because the entire conditional statement is all done. So we get to line 24, which says, mm, okay, because my screen is still displaying the old code. So p gets p divided by 2, so that becomes 8. There we go. And then where do we go? Line 24 is the last line of the block statement that is here from here to here, which is the statement that we're supposed to repeat for the while loop. So what do we do when we hit the last thing that we need to do in the while loop? We have to go back and ask the question. So what line do we go back to? We go back to line 18. That is correct. Okay, so we go back to line 18, and then we ask the question again, which is, once again, x does not equal to 0 is, okay, let's check it out. X is 3, and x does not equal to 0 is true. So then we go to line 19 again, and then we multiply d by 10. So d is still a 0, because 0 times 10 is, oops, okay, wrong tool. It's not the wrong tool because my palm touched the bottom rail of the tablet. So I'm going to use my little ruler here to block it so I don't accidentally touch it. Okay, so after on line 19, we reevaluate, we multiply 0 by 10, it will just do it a 0. And then we get to line 20 again. X is 3, P is 8 this time. So 3 is greater than or equal to 8 is still false. So I'm going to say that. And then we go all the way to line 25 again. And then P is divided by 2. Okay, wait. Something is not right. Doesn't seem right to me. Yeah, that's 1, but I think there's something else that's wrong too. Line 20. Okay, what did I miss? Hmm. Let's see. We go 17. Oh, okay, that's fine. Okay, so we only got 3. Line 20. Go straight to line 24. Okay, all right. So line 24 is correct after line 20. Yep, okay. And then we divide p by 2, so it goes from 8 to 4. And then we go back to um, 18 again. And then on line 18, x does not equal to 0 is true. On line 19, we are still multiplying d, which is a 0, by 10, which is then still a 0. Okay. And now we have to continue this here. And this time, I'm going to have to move this to the side over here and continue with the line. So I'm going to try my best using just hand drawing the straight lines here. Okay. So after line 19, where do we go? We go to line 20, and then we ask that question again. Okay, line 20 is asking, is x greater than or equal to p? It is still false. We go straight to line 24. We divide um, p by 2. So it is 4, and 4 divided by 2 is just 2. We go back to line 18, and then we say x does not equal to 0. It's still true because x basically has not changed. It still has a value of 3. And but this time when we go to okay, line 19 is still not going to do anything really important. It's still a 0 here. But this time when we get to line 20 asks, is x greater than or equal to p? And this time it is true. It is true because x is 3, p is 2 at this point. Okay, so it is true. So where do we go when the condition on line 20 is true? Line 21. That is correct. So we go to line 21. Line 21 says, let's subtract p from x. So x is 3 right now, so we have 1 left. And then we add 1 to d on line 22. So d gets 0 plus 1, which is a 1. And then where do we go? After line 22, where do we go? Sorry? It is not line 18 because it is not a loop. Okay? Well, I should say this, we are nested. We are still inside the conditional statement. We are just done with the very last thing we need to do here, which is part of the conditional statement. So where do we go after line 22? Line 24. Okay, line 24 is sequential to the conditional statement on line 20 to line 23. Okay, so line 24 is where we go. All right. So if you are looking at this and go like, I have no idea where to go, that means you might need to look at this C code here and convert it into a flow chart first. Okay, because once you convert it into a flow chart, it becomes more clear as to what you need to do with this code here. So I can do some conversion, I can go back and convert it into a flow chart after this. So we get to line 24. Line 24 is going to divide p by 2 again. So now it is 2 divided by 1, which is just 1. And then we go all the way back to line 18 again. Line 18 is still asking, is x not equal to 0? The answer is, yep, it is still true because x is 1. Then we get to line 19, and this time it has something to do because d is 1. 1 times 10 is 10. So d is now 10. Then we get to line 20, and then we are asking, is x greater than or equal to p? The answer is true because both of them are ones. X is 1 at this point. P is also 1 at this point. 1 is greater than or equal to 1 is true. So that means we go to line 21. We subtract 1 from 1, and x becomes 0. And then we get to line 22, which is d equals d plus 1. So D is 11 already. D is 10 right now. It is now 11. Then we get to line 24, which is P divided by 2. You can call that your 0.5. You can call it 0. Doesn't really matter in this case. So now we go back to line 18. And then x is finally 0. So x does not equal to 0 is false. And then we are done. We go to post right after that. So that is the trace of this particular algorithm. It is a little bit time consuming, okay, but the format of this question is obviously a little different from the other ones. This one is just asking, do you know the structure of the code? Can you follow it? And give me the trace, okay? And this is the way we trace it. So let me go back and kind of give you a diagram, okay, of this code here. So let me go back to the previous page and then use a flowchart, draw a flowchart to do this, okay? So I'm going to combine lines 15 to 17 into one single block because there's no decision to be made. There's no reason to kind of split it. Okay, so I'm just going to say line 15, line 16, and line 17 are combined into this block here. And then we get to a while loop. A while loop it looks like this. Okay, you have a decision to make, and if the decision is true, or if the answer is true, you got a block of code to perform. Okay, so I'm just going to leave myself some space here. to be kind of long. And after this block of code is done, you need to go back to the diamond. Okay, so you kind of go like, you have to go back like that. And if the answer is false to that question, then you exit the entire thing. Okay, so there's nothing else to do. You just exit. That's the general diagram or general shape of a while loop. Now, have we talked about the flow chart corresponding to a while loop? Yes, we did. Okay, except this time, the block of what we need to do is kind of big because there are a few things that we need to do. So within that entire block, okay, so this block here is corresponding to this open brace, and the end of this block is corresponding to this brace here, the close brace, because that is one single block statement. What is the purpose of a block statement? It's like a zip file, right? If you have multiple things that you need to put into where one single file is expected, then you can use a zip file because a zip file contains multiple files within, okay? And that's exactly what we're doing here because we got a few things that we need to do here, but since the while loop says I only want to do one single statement, you go like, okay, fine, I will combine those three things that we need to do into one single block statement, and this is the one statement that you need to perform. Is that okay? All right. So within that block, okay, from the open brace here to the closed brace over here, then the first thing we need to do is fairly straightforward. That one is just line 19. I'm just going to use line 19 here. And then the last thing we need to do is also fairly straightforward. It is just whatever is specified on line 24. In between, okay, from line 20 to line 23 is a conditional statement that has no else, okay? So now we draw the shape of a conditional statement. It has a diamond too because it has got a decision to make, but this time there's no looping back, okay? When this is all done, then it merges with the other side of the diamond, and then it just continues forward to whatever is following it. So that's the general shape of a conditional statement. So now um, I would also document the diamonds. So for the top diamond, this diamond over here, the condition is specified on line 18. For the embedded diamond here, the decision or the condition is specified on line 20. So that means this block here is corresponding to the block that starts with this particular open brace and ends with this particular end brace. So that means line 21 and line 22 are inside this particular block here. So that is the structure of the flowchart, given the text representation of the same logic. Is that okay? All right. So once you have the flowchart, it makes it easier to trace, because you just follow the arrow, right? You evaluate the condition, true versus false, true versus false. So let me just kind of label the true versus false as well. So now you have, so the first thing you need to do is to convert from the text form into the flowchart, and then you follow the flowchart in the trace. Is that okay? And the way to convert it from the text representation to the flowchart is by BNF. Okay, the BNF is what specifies the structure based on where you find the word if, where you find the word else, where you find the word do, and where you find the word while. And also where you find open curly brace and when you find where you find the closed curly brace. So all of those things combined are combined in order for you to help answer this question. All right. Do we have any questions about number 3 out of 4? No questions? All right. I'll give you guys a little short break by taking roll. Okay. So I know this is college, it's not high school, but I still feel that it is important for me to take roll. Okay. So that's what I'm going to do. So let me here, unhide that. Okay, today is the 24th, and the word you need to take a row is nested, which is aptly named because what we have been talking about is the nesting of statements. So I think you guys should be able to get into it. Okay, I specified the correct time. Yep. And I'm going to switch back to, oh, actually, I want to switch back to here to the last question. All right. That's question number 4. All right. So does anyone need any more time for the row taking activity? We all good? Yep. Huh? Um, yep. You missed that entirely. All right. So you good? Okay. All right. All right. So this is the last one. This one is also a nested kind of deal. The slash is a division. Okay. So and I think that's what we need to know. The slash is a division. All right. So we're gonna follow the trace of this code. Okay. This one has got 4 variables. We have x, p, q, and d as our you know local as our variables. Okay, so we'll go ahead and say there's a line number. Okay, there is X, P, Q, and D, and then the comments. Okay, there we go. And just draw straight lines, as straight as I can do it by freehand. There we go. Okay. So once again, the program does not, or the question does not say anything specific about the known values of the variables. So that means they're all unknown to begin with. Line 10 is easy. Okay, x ends up with a value of 21. Line 11, p ends up with 100. Line 12, uh, q ends up with 9. And in line 13, 0 is going to be in D. Okay, so that's the easy part. Okay, just sequential stuff. And then on line 14, we have our while loop. We have to evaluate the condition of p is greater than or equal to 1. So is p greater than or equal to 1? P is 100 right now. Obviously, it is greater than or equal to 1, so we say it is true. If the condition of a while loop is true, we go into the body of the loop, which starts on line 15. But line 15 is the starting point of a nested while loop, and this time we're asking is x is greater than or equal to p. All right, so let's check it out. X has a value of 21, p has a value of 100, so x is greater than or equal to p is false. And where do we go? Okay, so this is a decision point again, right? Because every time you see a condition, it means depending on the value of the condition, we may proceed in 2 different ways. So the question is, where do we go this time? We go to line 19. That is correct. Okay, because if the condition of a while loop is false, you get out right away. But somebody may say, but Tech, we haven't even gone through one iteration. Well, that's the whole thing about while loop is you check the condition first, and in certain cases, you don't even go through one single iteration. So we go straight to line 19, okay? And line 19 says we want to divide p by 10 and then put it back into p. P is 100 right now, divided by 10 is just 10. We put it back into p. And then on line 20, we divide We divide P by 3. I think that's meant to be Q. Okay, so I think I made a poo-poo here. This is supposed to be Q, and the original code is wrong also. That's supposed to be Q. All right, so I'm just gonna make a note here. Okay, this is supposed to be Q. Q equals to Q divided by 3. So Q was a 9, so now it is a 3. Okay, there we go. All right, and then where do we go? We're at the very end of a while loop. So which line do we go back to? I'll give you two choices. Are we supposed to go back to line 14 or are we supposed to go back to line 15? We're supposed to go back to line 14. We're supposed to go back to line 14 because the loop that starts with on line 15, it ends on line 18. Okay, so we're beyond that already. So we need to go back to line 14. So on line 14, we ask the question again, which is P is greater than or equal to 1, and P is 10, so 10 is greater than or equal to 1 is true. Then we go to line 15 again. Line 15 is asking, is X greater than or equal to P? Well, 21 is greater than or equal to 10, so this is true. Then where do we go? The condition of line 15 says it is true, so where do we go? Line 16, very good. So line 16 says, let's subtract P from X. Okay, so line 16. So X is 21 right now, and we're subtracting 10 from it, so that becomes 11. And then on line 17, we add Q to D. D is 0 right now, and Q is 3. Hmm. Okay, I think that's fine. Okay, so what is Q plus D? That would be just 3. So we put a 3 to here. And then where do we go? We are now on line 17. Where do we go next? We're at the end of the statement corresponding to a while loop. Where do we go? No, not yet. Okay, so this is a loop, right? It's a loop for a reason. Okay, what does a loop do? Yes. So where do we go? We go back to line. Hmm? But which line are we going back to? 14 or 15? 15. 1 5. 15 is where we go. Because this loop is nested within the outer loop, so we have to go back to the earlier point. Okay, so we go back to line 15, and line 15 is asking, is X greater than or equal to P? It is still true because 11 is greater than or equal to 10. So now okay, so this would be easier when you have when you're on an actual piece of paper. Okay, all right, so what we do is we go to line 16 again. And line 16 says, let's subtract P from X again. So X is 11, so now it becomes a 1. And we go to line 17. Line 17 says, D and Q, we have to add that. So that means, this is now a 6 as D. And then where do we go after that? We go back to line 15. Okay, that's the whole behavior of a loop is at the end of the statement of a loop, you have to go back to re-evaluate the condition on the line where the while is. Okay, so we go back to line 15 and then we evaluate x is greater than or equal to p again. This time the answer is false. This is when we get out of the nested loop. And then where do we go next? This time we go to line 19. That is correct. Okay, we go to line 19, which divides p by 10, which is, so 10 divided by 10 is 1. So we put a 1 here. And then on line 20, I remember I made a mistake. That is supposed to be q equals to q divided by 3. So that becomes 1 as well. And then we get back to, this time, where do we go back to? We're done with line 20. Oh, right. Sorry. Here we go. Come on. There we go. All right. So we are on line 20 right now. We're done with line 20. Where do we go to? Line 14. That is correct. Okay. So line 14 is where we go back to, and then we evaluate p is greater than or equal to 1, which is still true because p is 1 exactly right now. So the condition is still true. We go to line 15, which evaluates whether x is greater than or equal to p. That is also true because both of them are ones. Okay, x is 1, so is p. So we go to line 16, we subtract p from x, so x is now 0. And we go to line 17, we add q to d. Q is 1, we add that to um, d, so d is now 7. And then where do we go? Okay, this is kind of like a repeating pattern here. So after line 17, where do we go? Back to something, 14 or 15? 15 is correct. Okay, so now we go back to line 15, and line 15 is asking the same question, but the answer is different this time. X is now 0. P is still 1. 0 is greater than or equal to 1 is false. And because the condition is false, where do we go next? Line 19 is correct. So now line 19 says we want to divide 1 by 10. You can write down 0.1, you can write down 0. Either way is fine, doesn't matter. And then we go to line 20, which is dividing q by 3. So it is going from 1 to 1/3. So you can say 1/3 or 0.33 here. And then we go back to line 14 this time. And it's asking, is p still greater than or equal to 1? The answer is false. And then we get to post. We are done with this trace. All right. So what does the flow chart look like for this particular code? Okay, because that's kind of the real focus here is, can you convert the text representation into the flow chart? So that's what we'll do next. Okay, we'll convert that. Okay, so let me hide the other code here and make sure that we show enough of this. Okay, there we go. All right. So we have a block, of things to do here. Once again, I'm just going to quote the line numbers. So line 10, line 11, line 12, and also line 13 belong to a block, because they don't really, we just have to remember to execute these things in sequence. That's all we need to do. And then we have a while statement. So every single time you have a while statement, it looks kind of like this. Okay, so this time I'm going to draw it a little bit differently. If it is true, then we got potentially a big block of things to do. But after this thing is done, we want to go back to reevaluate the condition. So the condition that we want to reevaluate is on line 14. So I'm going to put line 14 here to specify where are we getting the condition to evaluate. If it is false, if the condition evaluates to false, then we're all done because the loop, the while loop starting on line 14, ending on line 21 is the last statement of the entire algorithm. There's nothing else to do when the loop is done. Okay? So now we look into what is inside the loop. In other words, we're looking into the text and we're asking what is between this open brace on line 14 and the closed brace on line 21. Well, a bunch of stuff, okay? First of all, we have another loop. So now you say, okay, well, we have another loop. What does the loop look like? Same thing, okay? If it is true, Then we got a block of things to do. And then after this block of stuff is done, we go back to re-ask the question. If the condition is false, then we kind of go to whatever is specified after that. Okay. All right. So the question is, what condition are we going to specify in this diamond here? Well, it's whatever condition we specify on line 15. So now I have to write in a kind of small way. That's okay. I got it. Okay. Now the question is, what is inside this block here? That would correspond to whatever the block statement is, starting with the open brace of line 15, ending with the closed brace of line 18. So we only got two things to do here, which is corresponding to line 16 and line 17. After that is done, okay, when we're done here, so when the condition of the loop is false, then we get to here. That would correspond to line 19 and line 20. 19 and line 20. And when that is done, we simply exit the loop, which turns out to be, um, well, we exit not the loop, sorry, I take it back. We are done with the entire block statement, which then goes back to this merge with this particular line, and then we go back to line 14, and then we ask the question again. So the key to get this answered is to understand how to read the code and understand the structure of the code and represent it in a flowchart if that is what you do. Okay. Um, I would say eventually, actually within the duration of this class, I hope everybody can do it without a flowchart or without having to represent everything in a flowchart before they can figure out the logic. All right. So do we have any questions about these four questions? Those are the four questions from 1999. Yeah. So we're good. Mm-hmm. So one thing you can practice, okay, because I know some of you want to practice, which is reasonable. I mean, that's how we can get better at this stuff. So to practice, I'm giving you guys a homework assignment so you can practice. So the homework assignment is due on Wednesday, so you only got 2 days to work on it. But given the lecture today, okay, given what we talked about today, I think the homework assignment is not going to be very time consuming. And it is right here. It's called nested trays. And let me go there. So this is the code that you have to track, okay? And you have to give me a trace, just like with the loop homework assignment, except this one is nesting. It has a conditional statement nested inside a while loop. So you kind of have to figure out, what to do with this one and kind of give it a try. All right. Any other questions before well, okay, I'm gonna give you guys, some suggestions. If anyone is thinking about, okay, when is Tech gonna give us the study guide for exam one, there won't be any coming from me, okay, because the study guide is something that you should be creating all along, okay. In other words, for every hour in this lecture, you have to spend two additional hours, and part of what you do with those two additional hours is to create your study guide. It can be just your notes. It can be just your notes, your annotated. You can use my content as a starting point and put your own annotation on it. That can be your study guide. Okay. Different people do it differently. You may do it in a certain way that may be entirely different from the next person. Okay. But you got a week. Okay. This is Monday. Our exam is next Monday at exactly the same time. Okay, we're going to use all 80 minutes for the exam. Okay, so you have 1 week to get ready for the exam. It's open book and open notes, which means for the most part, you just need to know, where to find what material. There's no need to memorize things, but you do need to understand the content of this class. There's a huge difference between understanding versus memorization. Okay, one I'm really good at, the other one I totally suck at. Okay, I can tell you I suck at Memorization. If you just give me a phone number, like a 7-digit phone number, not even a 9-digit one, by the time you get to like the fourth digit, I would have forgotten the first three. That's how bad my memory is. But if you ask me to understand something, that's what I do. Okay. And to be successful, not only in this class, but in software engineering as a whole, or anything that is computer related, you have to understand things. Okay. That's really, there's no option now. I would say 30 years ago, people who are very good at memorization and people who work really hard, they would be successful as a software engineer. There were still a lot of jobs where you have to follow things, you just have to follow the instructions and just kind of do things like repeated repetitively, and people will still be successful. And what do you think are doing those jobs now? Things that are fairly routine, there's not a whole lot of variation, no problem solving involved. You're just repetitively doing the same thing again and again. And they can all be done on a computer. Who are doing all of those things now? AI and the scripts that AI generates. Okay, so we are not even talking about AI itself. The scripts that are generated by AI can do all that already. So that means the only thing that need people to do would be things that the AI cannot do. And that boundary is shifting basically all the time. So you have to be agile and be able to kind of like float with technology. So you leave what can be done using AI and you leave it to AI to do it. But that doesn't mean that you don't have to understand the things that AI can already do. You still have to understand it. Why do you think that is important? So let's just say that you go to ChatGPT, okay? You have this great idea. I can make this app and I'm gonna make a lot of money, okay? So you go to ChatGPT and say, okay, write me an Android app that can do, and then you describe it, okay? And you say, okay, give me the source code in Kotlin, which is the programming language that you need to write an Android app. It gives you the whole code, okay? And then what do you do? Hmm? Sorry? Copy and paste, and then what do you do? So you run the code, right? So there are a few options here. Okay, so once again, we're talking about decision points, so we are now at a diamond. Okay, you copy and paste the code that the AI generated. Okay, so let's just say that there's no syntax error, the code seems to be fine, it compiled just fine, and it generated an app for you. Okay, so now you have two ways to proceed. One is I'm done. I'm just gonna release the app to the whole world, and I'm gonna reach. I'll be rich in a week at the most. Okay, or you can test it first, right? You can test out the app to see whether it works the way that you think it should work, right? And what does that entail? You have to know what the app is supposed to do to begin with. So even though you did not write a single line of code, you still have to understand the logic of the app, because you still have to compare the actual behavior of the app to what you expect the app to do. And what you expect the app to do is logic. So you still have that formulation of logic in your head. You may not be writing it in exact code like what we do in this class, but you still have that representation in your head. Not knowing exactly what the app is supposed to do when the end user interact with it in a certain way means you don't really know what the app is going to do. And not knowing exactly what your app is going to do and release it to the wild is probably not a good idea. Okay, so that means even though AI can code, once you specify exactly what the app is supposed to do, does not mean that we as humans do not need to understand the logic. We still need to understand the logic because we still have to be the gatekeeper of whether the app is correct or not. Okay, if it has a bug, then you can either go back to the AI and go like, okay, I want this app to do you can revise your instruction. Okay, you can say I forgot to mention that in this particular condition it's supposed to do this and not that. Okay, and then the AI may be able to regenerate a code to fix that problem. Okay, but you still have to go through that logic to find out what the problem is and describe the problem. Okay, and that's what we are basically training in this class to do, is not only to understand the code, okay, and the syntax, but also to understand the logic. All right. So I've just filled up all the remaining time of this class. I'll see you guys on Wednesday. Okay. So if you have any questions about the exam on next Monday, you can bring those questions to class on Wednesday. Okay.